Alright, so this video starts off chapter 6. We're starting with 6.1. It's going to talk about polygons with different angles inside the polygons, but then after 6.1, we're going to take a different turn and look just at quadrilaterals alone. So 6.1 is going to kind of be like a standalone section. So take a minute, draw this chart, label everything. We're going to, throughout this presentation, fill out the whole thing. Right now we're going to start by filling out the first few columns. So triangles have 3 sides, quadrilaterals 4, pentagons 5, hexagons have 6 sides, heptagons have 7, octagons have 8 sides, and an n-gon is what we're saying for any polygon with n number of sides. And when we talk about number of triangles, what we want to do is we want to be able to connect a shape into just triangles alone. So a triangle obviously only has one triangle. If you take a quadrilateral and you draw any quadrilateral, let's just go with that, and I can split it into 2 triangles. Okay, that's where we're going with that. Let me go ahead and delete that and erase that. When we look at a pentagon, if I take a pentagon, how many triangles can I split that into? I can split it like that into 3 triangles. And if you see a pattern, 3 minus 2, 4 minus 2, 5 minus 2, so let's keep going, 6 minus 2, 7 minus 2, 8 minus 2, and then n minus 2. So as we're going through, we're going to start creating a formula for the sum of the angle measures. The sum of the angle measures will be something here. We know each individual triangle has 180 degrees. So 2 triangles, 360 degrees, 3 triangles, 4 triangles, and each time all I'm doing, because I'm adding a triangle, is I'm just adding 180 degrees. And for every single triangle I have, this is the number of triangles right here, for every single triangle I have, it's 180 degrees times the number of triangles. So we're going to stop filling out this chart right now. We're going to come back to this last column, and then we'll fill out the last column later on. So let's take a look. Ryan's parents are building him a sandbox to play in. It's in the shape of the hexagon. What is the sum of the measures of the interior angles? So what we want to do is we want to take all of these angles in this hexagon sandbox and add all of them up. So we're going to use this formula that we had on the last slide. The sum is 180 times n. Well, how many sides are there? There's 6 sides, minus 2. 180 times 4, and 180 times 4 gets you 720 degrees. So all of the angles here together add up to 720 degrees. The sum of the angles inside a polygon is 2,340 degrees. Find the number of sides. So we're actually working backwards in this one. We know the sum. We are trying to find n. So when I plug that in, I'm going to divide by 180 right now to get rid of it. And when I do that, I get 13. And then I'm going to add 2. N is 15. So that type of shape, after we get to higher numbers, we stop naming them with a special name like octagon or hexagon, and we just call this one a 15-gon. So now what I want to do is I want to find the value of x. If I take some of these and I start setting them equal to each other, which we'll see later on in section 6.2, that opposite angles are congruent, it's not going to get me anywhere. What I want to use is the fact that this is a 4-sided shape. So let me flip back here. A quadrilateral has 4 sides, meaning 360 degrees. So 4 sides, 360 degrees, the sum of the angles is 360. So I'm going to take all the angles and I'm going to add them together. We've got 1, 2, 3, 4 angles. When I start combining like terms, I have x, 2x, x, and 2x. That's 6x minus 30. I'm going to add 30 to both sides. 390 equals 6x. And then I'm going to divide by 6. I'm going to get x equals 65. So now we have a quadrilateral here with angle S congruent to angle T, angle U congruent to angle W, and we know angle S is 2x plus 16, and we know angle U is x plus 14. So I want to find the value of x. Since I know those two are congruent, that means I have 2 of those, and since these two are congruent, I have 2 of these. Just like in the example before, all of them add up to 360. We have 2 x plus 14s, and we have 2 2x plus 16s. We're going to start solving. 2x plus 28 plus 4x plus 32. And we keep combining like terms. 360 equals 6x plus 60. I'm going to subtract 60 from both sides. $300 equals 6x, and x equals 50. Now keep in mind there may be a question where it will ask you to take x and plug it back in to find angle W or angle T or S or U. Just take 50, plug it in. Okay, so a regular polygon. A regular polygon is when all the sides and angles are congruent. So in a triangle, we're talking about an equilateral triangle. An equilateral triangle is one that has 3 congruent sides as well as 3 congruent angles. So a regular quadrilateral is a regular polygon that's 4-sided, meaning all 4 sides are the same. So we're talking a square. So now, let's go back to this chart. We had this filled out earlier. We went through, filled it out. Now we're going to look at each individual angle if I know that they're regular polygons. This column over here is specifically for regular polygons. Because all of the angles in a triangle add up to 180, if it's regular, each one's 60. Because we're doing 180 divided by 3. 360 divided by 4 gets me 90. 540 divided by 5 gets me 108. 720 divided by 6 gives me 120. 900 divided by 7, 128.57. Now, it's okay if you don't have whole numbers. We're talking about specific regular polygons, and when we split it equally, it's not always going to come out to whole numbers. And 180 divided by 8 gives me 135. So each individual interior angle is your total angles, 180 times n minus 2, divided by the number of sides. So we're taking what we had in this column, sum of the angle measures, and splitting it equally amongst the angles. So let's take a look at this example. A regular polygon with each interior angle being 140 degrees. How many sides does that have? So let me write the formula. Interior equals 180 times n minus 2 over n. Well, we know 140 equals 180 n minus 2 over n. I'm going to multiply both sides by n. That way now I have no denominator. I'm going to distribute on the right hand side. So 140n equals 180n minus 360. I'm going to subtract 180 from both sides. And then I'm going to divide by negative 40 to get n equals 9. And a 9-sided figure is a nonagon. You will have to know the names of all the polygons as well.